Here we are, the last video. The last little bit of radicals that we need to review are what we call conjugates, which we kind of already talked about, and how we can apply that to rationalize not just a radical, but when it's a radical expression. So we'll be doing kind of 2 out of the 4 examples in this section as well. So conjugates, like we already talked about, when we multiply them, the product will always result in an integer, meaning the radical will be eliminated. We use conjugates to rationalize denominators that use addition or subtraction. So when we're dealing with conjugates, the big factor to remember is that they are the same terms but opposite. So if we had a situation where we had 3 plus the square root of 5, just a basic example, its conjugate would be 3 minus the square root of 5. So it's the same terms, opposite signs. If we look at our first example here, we have 7 over 2 minus the square root of 10. Now, what we cannot do is we cannot just multiply by the square root of 10, because what would end up happening is we'd be going back and forth, back and forth, back and forth, but still having a radical. So what we need to do is multiply by the 10. Now, what you'll see is I put my expression instead of parentheses, because if you're taking a binomial multiplied by a binomial, means you're going to have to FOIL. So 2 minus the square root of 10, the conjugate to that, same terms, opposite sign, is going to be 2 plus the square root of 10. And just like the last section, whatever we do to the denominator, we also have to apply to the numerator. So we're also going to multiply the numerator by 2 squared root of 10. From here, we're taking 7 times 2, which gives us 14. 7 times 10, which we can't physically multiply them together, so we just leave it as 7 times square root of 10. We now FOIL the denominator. 2 times 2 gives us 4. We move to our outers, which gives us 2 square root of 10. Our inner terms are going to give us negative 2 square root of 10. And then our last terms, let's borrow a little bit here, is going to give us negative 100. At this point, we're going to look to simplify. Now, right now, we can't combine anything in our numerator, so it's just going to stay as 14 plus 7 squared root of 10. But now if we look at our denominator, first thing you're going to see, middle terms cancel out, which is good. That was the whole point of multiplying by the conjugate. So we're left with our first term, 4. Now, if you look at your last term, square root of 100 is a perfect square, which would simplify to negative 10. So 4 minus 10 gives us negative 6. Now, at this point, we would look to simplify if we can. And half of our fraction is able to simplify. So if you wanted to take the extra step, so I'm going to be honest, I will accept this as your final answer if you see that only half of your fraction can simplify, but I'll just take that extra step. We would look at this as, like we did in the last section, 2 separate fractions. So 14 over negative 6 plus 7 squared root of 10 over negative 6. 14 over negative 6 would simplify to, we can say, negative 7 over 3 plus, unfortunately, our second one, we can actually make that a minus, is 7 square root of 10 over 6. So either pause the video and complete example 20, or when you're done watching the video, go back and complete number 20. We are now going to do our last example together, which is example 21. We're dealing with the same concept, but now we have an expression in our numerator and an expression in our denominator. Anytime you're dealing with an expression, I always recommend putting them in a set of parentheses. Now, the big issue is not the numerator, it's the denominator. We can never leave a radical in the denominator. So we multiply by the conjugate. The conjugate is going to be 1 minus the square root of 5. Same terms, opposite sign. Whatever we multiply the denominator by, we also multiply the numerator by. Now, this is why it's a little trickier, because we're now going to have FOIL in our numerator and our denominator. So we're just breaking into smaller steps. First, 3 times 1 gives us 3. Outers gives us 3 square root of 5, negative 3 square root of 5. Inners, square root of 2. And then our last, negative times a negative, positive, square root of 10. We now do the same thing on our denominators. First, give us 1. Outers, negative square root of 5. Inner terms, positive square root of 5. And then our last, negative square root of 25. From here, we look to simplify. Now, right now, nothing in our numerator can simplify. So we leave it as is. In our denominator now, just like before, middle terms are going to cancel each other out. And then our last term, square root of 25, is a perfect square. This is then going to leave us with the square root of negative 4. At this point, I would like you to go back to example 20 if you did not get a chance to do that, or complete example 22. Finally made it to the end. If you have any questions, please make sure you ask.